Hello and what's up to you all pre-matriculants, grade 11 Mindsetters. This is once more another Triple M day, your Mindsetters Maths Monday with me, AB, Abram and Dina. How are you, Dina?
Very, very well and ready to go.
I can see you all colorful and in summer, and it means one thing, it's happiness. And we're doing what we love most, hey?
Absolutely, working with children.
Of
Or
course.
teenagers.
Yes, of course. Well, now...
Pre-matriculants.
Pre-matriculants, adulthood kicking in.
More, that's right.
Right, what are we doing with them today?
Grade 11s, we're going to be working with some simultaneous equations, those equations that we try and solve for two variables at the same time. Really nice and easy, so I'm sure you're going to have loads of fun this afternoon.
And I must say, they love this part of maths. They enjoy it. Otherwise, Mindsetters, we'd love to hear from you. How was your day at school? How was the maths period, just to be specific, today? Did you enjoy it? Was it fun? What did you guys do? Share with me on Facebook at facebook.com/LearnExtra or tweet me at LearnExtra. And lastly, download your notes all for free at learn.mindset.co.za. Remember, if you download today's notes, there's a test yourself questions whereby if you answer them correctly, you stand a chance of winning an awesome airtime voucher, proudly sponsored by Vodacom. So I have posted the link on Facebook, whereby there's a link for your notes and a link for the form where you need to submit your answers. Already, there are so many other Mindsetters that have won the airtime. It's worth 110 Rand. So imagine the many people that you can call your friends, your family, your cousins, and your teachers. Otherwise, tell us more, Dina, also about the challenge question.
I will in a moment, but I want to know the answer. Do you twit somebody or do we tweet somebody?
Tweet.
Okay,
Are you trying to tell me something, Dina?
I won't go there.
Because I know the term that you're trying to tell me, but it's fine. I'll deal with it during the break. We tweet.
Okay, we tweet each other. That's fantastic. Right, grade 11s. It's about a little bit more about the question. Let's just see, first of all, what are we going to be doing in our lesson? We are going to solve equations, but I'm going to have a variety of contexts. They're not going to be the same old questions that you're used to. We're going to look at different types of questions, just to keep it really interesting. And then the challenge question, it's also a little bit interesting because you've been doing quite a lot of work with quadratic equations. So it's not your standard question. I'm really trying to get you to think outside the box, because when you do that final exam, there may be some questions there that you've not seen before, so you need to, we need to be able to answer questions that we haven't seen before. And so the challenge question is, if a and b are the roots of the equation, x squared minus 5x minus 1 equals 0, you need to determine the value of three questions. What is the value of b squared minus 5e minus 1? What is the value of a squared minus 5a plus 1? And what is the smallest possible value of a over b? So grade 11s, get going. Let's hope that challenges some minds. And we'll get that answer a little later. But for those of you who really know how to do simultaneous equations, you feel you've got it all under wrap, then let's get your answers on the page. So get going. While you're doing that, I'm going to go over some of the tips for working with simultaneous equation, especially for those of you who may not have yet covered it at school, or you may just want to sit back and say, right, I want to really grasp the section. So sit with me, let's go through it together, and hopefully within the next 10 minutes you'll be able to be up and running with us. Okay, so simultaneous equations, basically what we're trying to do is we have two different variables that we have to solve. Now, if I only have one equation, it's going to be impossible. It's like y equals 2x minus 1. If I have a y and an x, I can't solve for y and x. Y and x could be many things because I've got two variables. So if you were trying to solve for two variables, you must have two equations. But if I take a step back, if you have one equation and you want to solve for the unknown, then you must have one unknown. So one unknown, one equation. Two unknowns, two equations. And then if you have three unknowns, if you're solving, for example, for a, b, and c, then you must have two other equations in a, b, and c. And in that way, you'll be able to find all three values. Usually, we don't really work with that at high school, but for those of you who are doing an extended course in mathematics, you use a matrix to solve for that. And so anyone who's done work on matrices will know how to solve for three variables and more. But the whole point about solving the number of unknowns is you've got to look for those number of equations. One unknown, one equation. Two unknowns, two equations. Three unknowns, three equations, etc. So Simultaneous means we are solving for those two values that we don't know in the two equations at the same time. So when you solve for x and y in two different equations and you substitute into either of them, they will actually give you a true statement. We're not only solving for one value. Okay, so in solving simultaneous equations, we're going to be focusing on the linear equation, and we're going to make one of the variables the subject of the formula. So when we take the linear, let's say you look at two equations and you have y minus 2x is equal to 1. I have the option of making y the subject of the formula, or I have the option of making x the subject of the formula. And I want you to look at what we get in both cases. Okay, we've got, in this case, y is 1 minus 2x, and in that case, x equals y minus 1 over 2. Which of these two expressions would you use, and why? Yeah, I think some of you are choosing wisely. I would rather use this one because it doesn't have a denominator. So it's creating less arithmetic for me. Whereas this one here has got a denominator, so I'm going to substitute into a next equation, and I have to work with the denominators. So when you're focusing on the linear equation, we would like, just to be able to not have this, there we go, that's better. We would like to have the variable with a coefficient of 1, because that helps to keep us away from fractions. So this one, I was clever, the coefficient of y was 1. Okay, so it gives us away from the fractions, but because that coefficient of 2x was 2, we have to divide by 2, and therefore we get a fraction. So grade 11s, what I'm saying is, if you have the option, if possible, that's why it says here, if possible. So if I have like 2x minus 3y equals 5, then guess what? The x and the y terms don't have a coefficient of 1, so you have no choice. You have to go for one of those two, and you have to have fractions. So you only look at each of the terms. If one of them has got a coefficient of 1, solve for that one. And then we're going to take that linear, and we're going to substitute it into the non-linear equation. You'll find that sometimes they're fractional equations, they've got fractions in them, sometimes they've got squares, sometimes they've got cubes, it doesn't matter. So we always focus on the linear first. We take the linear equation and we make one of the variables the subject of the formula. Okay, so with that knowledge in mind, let's go and see what our first question looks like. Okay. Right, so here we have question 1. Solve for x and y, two equations, two unknowns. And we've got first equation, 2y minus 3x equals 3. Second equation, y squared minus 2x minus x equals 1. Which equation would you choose to focus on, and why? I notice that this one's got squares. That makes it non-linear. And we said earlier, let's start with the linear. So you give this one a number, and you give that one a number, because we have to give little instructions on the way. So from equation 1, I'm going to solve for the variable with coefficient of 1. This y's coefficient is 2, this x's coefficient is 1, so I'm going to have 2y minus a 3 equals x. And I've been very clever, I've avoided my fractions. I had the option of doing that. And I'm going to call this one, I'm going to call it a 3. Then I'm going to substitute my 3 into, where am I going to do? What am I going to do? Into my second one. Okay, so now, by doing that, I've got, in place of x, I'm going to replace 2y minus 3. So in place of x, put a bracket in, I'm going to replace it, put a bracket in, I'm going to replace it. So I have y squared minus 2 times 2y minus 3 squared minus 2y minus 3 equals 1. Right, grade 11s, work with me. Y squared minus, don't get tempted to take this 2 and multiply it into the bracket, because otherwise you're going to be squaring the 2 as well. There's a 2 times a bracket times a bracket. Let's multiply the bracket first. It's a binomial squared, so it's 4y squared minus 12y plus 9 minus 2y plus 3 minus 1 equals 0. Okay, grade 11s, let's hope there's no errors here. Otherwise, you'll let me know on the page. Y squared minus 8y squared plus 24y minus 18 minus 2y, and then I have a little plus 2 equals 0. Right, let's collect our like terms. So we've got a 1 minus an 8 is minus 7. And then I've got a 24 minus a 2, which is a plus 22y. And then we have a negative 18 plus a 2, which is minus 16, is equal to 0. So if we've got 7y squared minus 21y plus 16 equals 0, what are the factors of this trinomial? It must be 7 and 1. And then maybe it must be 4 and 4, or it must be 8 and 2, I think. So that is 14 and 8. And I'm not sure why that became a 1 all of a sudden. I'm sure some of you have spotted that. Why did it just become a 1? It should have been 22, right? Okay, so we've got a 14 and an 8, which gives us 22. So there are factors, 7y and y. And then we have the 7 goes with a 2, and the 1 goes with an 8. And we want it to be a negative 22. So y is 8/7, or y is equal to 2. So we're getting 2y values, and therefore x is going to be whatever we said x was at originally. X was 2y minus 3. So it's 2y minus 3. Or x equals 2y minus 3. So that gives me a little simplification of 16 over 7 minus 21 over 7, so it's minus 5/7. Just want to erase this. This looks like a little 1. And, okay, or x equals to 4 minus 3, which is 1. Now, grade 11s, you've actually got the option of actually testing this. So if you take an x of 1 and a y of 2, x is 1 and y is 2. Let's see what happens. If y is 2, 2 2s are 4 minus 3 is 1, so I'm happy. And if I test it in here, we said that y was 2, x was 1. So if y is 2, we get 2 squared minus 2. X was 1, so it's 1 minus 1. What do we get? 4 minus 2 is 2 minus 1 is 1. So we get the correct equation. And grade 11s, you must develop that resilience that if something's not working out, you've got to go and look for your mistake. So an equation is an ideal topic for you to be able to test your answers to validate that they're actually correct. So that's our first question. Abraham, did we have any queries on that?
No.
Oh, good. So we're going to move on to the second question. Okay, so this is interesting because these questions are not related to each other, but it does ask you to solve for a quotient if we have that equation. So you're solving for a quotient in x and y. Does that mean you have to have x and y's value? Well, let's go and have a look. Let's just take what we can, or actually work with what we can. We can find a common denominator. So it's 2xy, which means our numerator is now going to have a 2x squared. And our denominator for here, it's got a missing y, so it's minus 3y squared. And we're going to add 1 is equal to 0. So I can add the fractions. Remember I said let's do what we can. I can add the fractions. It's an equation, so I can multiply both sides by 2xy. So if I multiply this by xy, I'm left with 2 times 2x squared minus 3y squared. And if I multiply that by 2xy plus a 2xy equals 0. So I can find a common denominator. I can eliminate the common denominator by multiplying both sides. And now I can just tidy up. So I've got 4x squared. I've got a plus 2xy. And I've got a minus 6y squared equals 0. So I've got a quadratic, but in 2 variables. I can actually simplify this because it's a factor of 2. So instead of working with very large coefficients, I can make them much simpler. And then I can factorize as 2x and 3y and x and y. And if I have a positive 3 and a negative 2, I get 3 minus 2 is 1. So therefore, 2x is equal to 3y. And what was the ratio that you needed to get? We were getting a x to y. So x over y is equal to 3 over 2, or x is equal to y. So therefore, x to y is equal to 1 to 1. So sometimes you'll be asked to relate to the value of 2 variables without actually finding the value of each variable, which in this case we left as a quotient. But I think it's over to Abraham.
Thank you so much, Dina. It is the time where we need to take our break. But remember, if you're struggling anywhere, send us your questions at facebook.com/learnextra and do the test yourself questions. Submit your answers on the link that is provided on Facebook, and you stand a chance of winning an awesome airtime voucher, proudly sponsored by Vodacom. Challenge yourself with the challenge question. We'll see you after the break. Welcome back, Mindsetters. Now, thank you for all the comments on Facebook and the answers that we're getting on Facebook, and you guys helping one another. That's what we want to see on the page, you guys doing. If you don't know the page, it is facebook.com/learnextra. And welcome to all the newbies that have joined us. I'm having a request from Ayanda saying I should greet this mindsetter who's watching for the first time. Ayanda Trevor says I should greet Nokubonga, who's watching the show for the first time. So big shout out to you, Nokubonga, and welcome to the family. Dina, the mindsetters are asking about that question.
The last one that we just did.
Yes.
Oh, they are so clever. You know, they should all be here in the studio with us and just be working together, because they've picked up a little error on the signs, and that was quite correct. The 2x is equal to negative 3y, and therefore x to y is negative 3 over 2. So well spotted. I've corrected that already. Thank you very much. Is there any other pressing questions?
Other pressing questions are based on 2.1.
Yes.
Whereby mindsetters do not understand what happened. How did we get the denominator of 2xy?
Okay, so grade 11s, this is really grade 10 work. I've got a common denominator I've got a denominator y and a denominator of 2x. So what is my common denominator? It's going to be a mixture of those 3 factors. So 2 times x times y, all those 3 factors make up the common denominator. And if you make that your common denominator, then this fraction, it's missing the 2x, so it's got to be multiplied in the numerator by 2x. And the second fraction is missing a y, so it's got to be multiplied by y, both numerator and denominator. So this is the equivalent fraction of the difference of those 2. So your common denominator is always built up by all the factors. And then to get rid of the common denominator, because we've got a 0 on the right-hand side, we can multiply by 2xy on both sides. And that's what happened there, grade 11s.
Okay. Another pressing question.
Yes.
It's based on question 1.
Yes.
How did we get to the 12y?
Let's see if we go back there. It's binomial, so we're going back to grade 9. So it looks like we're fixing up lots of gaps in knowledge. This is 2y minus 3, which are multiplying by 2y minus 3. So I'm squaring a binomial. Squaring a binomial means there are 4 products: firsts, outers, inners, lasts. And the OI, the inners and the outers, can be added together. And in the OI, we've got minus 3 times 2, which is minus 6. And in the outers, we've got minus 3 times 2, which is minus 6. So minus 6y minus 6y gives us minus 12y. And I know that most students forget that middle term because they like to square the ends, and they forget that there are 2 products on the inside. So grade 11s, negative 12y comes from where? The OI, outers and the inners.
Thank you so much, my tutors, for those. And keep your questions coming. We'll still take them later on.
Right, I'm ready to get to 2.2 because I really like 2.2. I warned you, I said we were going to look at simultaneous equations in different contexts. And these are not really simultaneous equations, but they are dealing with solving for expressions in a very different way, where you have to link logically the various expressions. So it's not really simultaneous, but it is a logic that comes in solving. Not only, like in question 2.1, you had to solve for a quotient rather than solving for x and for y, and in a completely different way. We landed up with a quadratic in 2 variables. Okay, so 2.2, if a plus, I'd love you to be in the studio right now and read this for me. How would you read that? If a plus, and I know you're going to say to me a to the minus 1. I know you're going to say that, but what is the meaning of a to the power of negative 1? In your little minds, how is it translating? What is your mind application doing to apply the mathematical knowledge? Okay, so this is saying a plus, it's reciprocal. So when you take a plus 1 over a, I'm getting 3. And we need to find the value of a cubed plus a to the negative 3. Well, you possibly are saying to me, how on earth are we going to find a from that? Well, we're not. We're going to use our logic. And we're going to try and see what is it about a cubed plus a to the negative 3. What sparks your interest there? Well, I think it's that power 3. Because the moment you have a power 3, you talk about a cube. And if that's a cube, that's also a cube. And then we have this positive separating them. So it's actually the sum of 2 cubes, which I think you would have seen in grade 10. And mathematics is that one topic that you can never leave your previous knowledge sitting, hanging, drying out. You have to be using it all the time. Anything you learn in the previous grades, you are using all the time. So here's a classic question. I'm just going to rewrite it. I'm not sure what is happening over there. All right, so we're going to rewrite this, and we're going to say, the given, this is question 2.2, is that a plus 1 over a is equal to 3. And we would like to find out what is a cubed plus a to the negative 3. Okay, in the same way I asked you what is the meaning of a to the negative 1, I'm going to do the same thing over here, which is 1 over a cubed. Okay, for those of you who know how to factorize the sum of cubes, we take the cube root of the first, we take the cube root of the second, and we multiply by a quadratic. Okay, this is standard. Cube root, cube root. The second bracket's got a quadratic, and it's the square of the first, and you multiply those 2 together. Aha, what is a times 1 over a? A multiplied by its reciprocal is 1. You multiply the 2 and you change the sign. And you square the last, so it's plus 1 over a squared. Okay, so what have we got so far? We factorized the cubic and we landed up with this a plus 1 over a, which we now know is 3. So can you see I didn't have to go and solve for a. I can just rewrite the sum as 3. But what I don't know is what is this a squared plus 1 over a squared. And seeing from the previous question where you couldn't square properly, let's hope that you'll be able to square nicely now. What is a squared? Well, what is a plus 1 over a squared? Multiply it by itself. Grade 11s, if you have to, you can even write out both brackets. Outers and inners, don't forget. Inners, outers, outers, inners, doesn't matter how you say it. So if I square, I multiply the first two together. What is a multiplied by its reciprocal? A times 1 over a is always 1. So we now have inners is 1, outers is exactly the same thing. So it's plus 2 is equal to, not equal to, but you're going to add the lasts. So we have plus 1 over a squared. So when you square the a plus 1 over a, you get that. But remember that a plus its reciprocal was 3. So if I take 3 times 3, I'm going to equal that to 9. So I'm left with a squared plus 1 over a squared is equal to 7. And remember, that's what we were trying to find. How much is a squared plus 1 over a squared? That's now 7. So if we now just translate this information here, a cubed plus 1 over a cubed, let's go over that again. How do we factorize that? Cube of the first, cube of the last, cube root of the last, cube root of the first, cube root of the last. Square the first, multiply and change the sign, square the last. That's the formula for the sum of cubes. That was given to us as 3. We've just worked out that a squared plus 1 over a squared is 7. So we have that the sum of the cube and its reciprocal cubed is 3 times 6, which is 18. Okay. That a plus 1 over a equals something is a very big historical standard question. You see it all the time. And they'll ask you about the squares and they'll ask you about the cubes, but I don't have to solve for a. So sometimes in equations, all we want to is we want to find a value. I can work with a value of an expression and be able to interpret another expression in terms of that one. And I can still find what those values are. So something very different from simultaneous, but within the actual topic of equations, which is what we've been dealing with over for the last 3 weeks. Right, so then we're getting right back to having our comfortable solve for x and y. And what I really like about this question is it's got the quadratic and grade 11s. It's got what else? An exponential equation. But because you've been watching Mindset, you have been up to date with the exponential work, and you'll know that when we're solving for an unknown exponent, that we've got to get the bases to become the same base on either side. Same base. So we're not even going to touch the quadratic. We're going to rather look at the exponential and say, if we have a 2 to the x, that's saying the same thing as 2 to the 2y minus 6. And because the bases are the same on either side of that equal sign, we therefore can equate just the exponents. X equals 2y minus 6. Aha! Now I have been able to create my linear. So my linear was there, but it was hiding. And that's what happens sometimes. Remember in the notes we said you look, you focus on the linear, and you take that linear and you substitute into the quadratic. Well, here it was there, but it was hiding underneath an exponential equation. Okay, so that would be my first equation. This equation over here would be my second equation, and I'm going to substitute 1 into equation 2. So then I get x is 2y minus 6 squared plus y squared equals 20. And now we're going to keep pressing with our algebra. Grade 11s, this is a binomial squared. Remember to square the first. Outers and inners, what are they? Negative 24y. And square the last, plus 36, plus y squared equals 20. So we've got a 5y squared plus a 24y. 36 minus 20 is plus 16 is equal to 0. Okay, so what are my factors? I'm assuming this factorizes. 5 and 1, and 16 is an 8 and a true. So that doesn't quite do it. So maybe a 4 and a 4. That's 20. Yes, that's much better because that's 20 and that's 4. Great. So we've got a 5 and a 1. And we've got a 4 and a 4. So we don't really have to think about this. And if we carry on, y is minus 4/5, or y equals negative 4. How many are still with us? Grade 11s, happy? So x is then, let's see what x was. X was 2y minus 6, 2y minus 6, or x is 2y minus 6. So we've got a negative 8/5 minus 30, so it's minus 38/5, or x equals to minus 8 minus 6 is minus 14. Okay, so when x is negative 38/5, y will be that, and when x is negative 14, y will be that. Okay, so there was a lovely, rich simultaneous equation, but hiding underneath that exponential. Okay. Are there any questions on that, Abraham?
Not on that one.
Okay.
Yeah, but I have
Good.
pressing issue questions on a previous question.
Okay. Which one?
Question 2.2, sorry.
2.2, yes.
A lot of mindsetters don't understand how on the step where you factorized.
Yes.
Yes, that's the step they don't understand. Some are asking, where did you get that plus 2xy? I think it's the third step.
This one here.
Yes, 2.2.
So it's not 2.1, it's not 2xy, huh?
No.
Because 2.2 doesn't have an xy. 2.2 is made up of a's.
I think that plus 2xy it's for 2.1, and then the others, they're factorizing on 2.2.
Okay, the factorizing of the cubic. I'm going to really do a simple cubic. Factorizing cubics. Because our work in mathematics is around quadratics and cubics. But I'm going to only do the sum and difference, which is in the grade 10 syllabus, in the CAP syllabus. So if you haven't done it, you will do it this year. But if I have a cube, minus 1, so these are both cubes, I take the cube root of the first. So in here is the cube root of the first term. And in here is the cube root with the same sign. So this would be minus the cube root of the last term. Okay, then the next bracket is made up of square this one, square. Then the middle term, this term over here, will be multiply and change sign. Multiply and change sign. And the last one will be square. So that's how the second bracket gets made. I'm going to square that first. I'm going to multiply these and change sign, and I'm going to square that. So if I now take this example, x cubed minus 1, work with me. Cube root of x cubed, oopsie, cube root of x cubed, cube root of -1. So it becomes a linear. Okay, what comes into your second bracket? I square what I just found as a cube root, so it's x squared. I multiply and change the sign, so x times -1 is minus x. And if I change the sign, it becomes positive x. And then if I square the last, -1 times -1 is +1. Okay, and whether it's the sum or the difference, it works in exactly the same way. If it's the sum, then we would get x cubed plus 1 would be cube root. So just change sign. And then the second bracket, let's square, let's multiply and change sign, and let's square. So there are a couple of sum changes. So it's only if it's the sum and difference of two cubes, then that's the way that you factorize. So my a cubed plus 1 over a cubed, I've just followed that formula, and I'll leave you to go and play with that while we take a break shortly.
At least you've got something to do, Mindsetters, other than the challenge question, of which I think after the break we'll be solving it.
Yes, I'm keen to see how many of you got it.
So many answers, I must say, but otherwise stay tuned to get the right answer. Do the test yourself questions also to stand a chance of winning an awesome item voucher, proudly sponsored by Vodacom. See you after the break. Welcome back, Mindsetters. Now I'm just looking at the challenge question answers that we have on the Mindsetters. Totally different from each other, and yet we're all doing the same grade. But I think we'll get the right answer, right, Dina?
Let's hope that up on this board we don't make any sign errors, then we'll get the answer.
All right. For the competition, Mindsetters, remember you can still do the test yourself questions up until 10 p.m. today. So you've got that opportunity. And so many other Mindsetters are asking me, what's my name? I must say that Dina has said my name for more than 50 times today on some of the equations, so you should know my name. That's what I'm going to say.
Start with your alphabet.
Yeah.
Cool. Right. I think it's time for the challenge question. Let's have a look at what it said. A and B are the roots of the equation. Right, grade 11s, what does that tell you? A and B are the roots of the equation. And we need to find what is the value of b squared minus 5b minus 1. Well, I really didn't want you to have to go in and solve for b, because it's really asking you for that expression. And if you have a look at how you connect that quadratic equation to the given expression, I think you can see some similarities. Okay. So firstly, what does that mean? And secondly, what is the connection between those two? And I think it's quite easy to see that when we are told that something is a root, then we know that in that equation, the solution is A and the solution is B. So again, I have a context where I'm using two variables or two unknowns, and I'm not really using a simultaneous equation. So a lot of work in mathematics is surrounded a lot of problem solving is surrounded about finding various expressions in terms of each other, and we try and really reduce it down to two if possible at school level. So yes, if they are the roots of that equation, I'm dealing with one variable, I'm dealing with another, one unknown and another unknown. And therefore, if I was to now look at what is the meaning of this expression, if b is a root, then b squared minus 5b minus 1 must be equal to b squared minus 5b minus 1. It is a root, must be equal to 0, the expression. So A needed to be 0. And if you got that, then you stand a chance of winning that prize. What about B? Well, B is not straightforward. When I say challenge, today I meant a challenge. You're not going to get away without it hurting those neurons. So it now does not look anything like the equation b squared minus 5b, but they did tell me that a is a root. So if I can get my equation or my expression to look like that, then maybe I've got a value. So I've got a squared minus 5a, which is the same as that equation. But I don't have a minus 1. So grade 11s in maths, we're very clever. When we want to get to minus 1, we add minus 1, but we don't want to unbalance the expression. So at the same time as we're adding minus 1, we're taking it away. So minus 1 plus 1 is 0, but let's not forget that we had a minus 1 there. So we now have the actual minus 1. Actually, no, let's not get ourselves carried away here. Let's keep looking at this expression, because this is what we're trying to find the value. So far, I've got a squared minus 5a, and I've added in the minus 1 and I've taken away. So these are the bits. I'm adding minus 1 and I'm taking it away. So I've got a 0. But up here, I've still got that plus 1. Okay? So this little bit here is equal to how much? A is a root. So if a is a root, when I substitute it back in there, I'm going to get 0 plus 2. So that gives me 2. So grade 11 so far, if you got the first one as 0, the second one as 2, where we had to utilize the additive inverse, a very common tool that we use in mathematics to add and to take away by using the additive inverse, then you still stand a chance of winning that airtime. And then the smallest possible value of a over b. And since a and b are the roots of that equation, then I am left with no choice but to actually solve for x squared minus 5x minus 1 equals 0. So if a and b are my roots, and I want to know what is the minimum fractional value, I actually have to solve. Now, we were looking at the various questions that pop up, and we saw that you asked why I wasn't using the quadratic formula to solve these equations. Well, grade 11, simply because factorizing is much quicker if we have the factors. I don't have to substitute, I don't have to work out square roots, I don't have to work plus and minuses out. It's all there in one statement. But in this one, I cannot find factors of 1 that when subtracted give me 5. So therefore, I'm actually going to have to use the formula. X equals to minus b plus minus the square root of b squared minus 4ac all over 2. And so I get x as 5 plus root 29 over 2, and I get the other x as 5 minus root 29 over 2. So we want to know what is the smallest value. So one of them is a. A is the root. X is the root. The solution, that's a synonym. Or x or b is equal to 5 minus root 29 over 2. Okay. We just don't know which one's which, so we're going to test. If I take a divided by b, and I say 5 plus root 29 over 2, divided by b would be times 2 over 5 minus root 29. And so I would get 5 plus root 29 over 5 minus root 29. Okay? And I could also take the b over a. So let's just get a little help from my irrational calculator here. Let's just go here. And we want this. What is 5 plus root 29? And we want to actually get that into a bracket. There. And we want to divide it by 5 minus root 29. Okay. We also need a bracket, otherwise we're going to, oopsie daisy, that's a minus there. And we need a bracket here as well. So what do we get? Oh, it's not letting us do anything. I wonder why. I don't think we can go back. So let's just go 5 plus root 29 equals divided by 5 minus root 29 equals. There it is. Now it's giving us a sum, a little sum there. And that's negative 26,9. So that's negative 26,9. Whereas if we had to divide it the other way around, let's get our little irrational calculator here and just divide it the other way around and see what that would give us. 5 minus root 29. And we're going to divide that by 5 plus root 29. What do we get? We get that, which is 5,3. So we wanted to know what was the smallest value. So this value is actually the smallest. That other one, it would be positive, since your 5 minus root 29 over your 5 plus root 29 would be bigger. Would be bigger than 5,3. All right, so that was a challenge question. The ratio, the smallest value of A over B was negative 26,9. AB, was there anybody who got that?
Someone close to that.
Okay, I'm glad to hear that.
Yeah, I think there is one mindset that got it right.
Awesome. So we will look through it now and make sure that all of you go into that little drawer that can get that little prize. Okay, right, so I think it's time for questions, Abram.
Yes, but I must say that this prize is exclusive, Dina. It's only for the test yourself questions, because the challenge question, mindsetters think it's very easy, and yet the test yourself questions are just multiple choice questions.
Oh, okay, sorry, got that wrong.
Yeah, so it's okay. Mindsetters, get the test yourself questions, answers being submitted on the link that is on Facebook to get your chance or your name through to the draw. Here's a question from Jabulile. Jabulile says, I'd like to know about checking my values of x and y, if are correct or not, because in some situation I find that they don't work for me, so what must I do?
Okay, Jabulile, that's a very, very good question, but I'm unfortunately not going to have a good answer for you, because I would say that 99% of the time, if you've tested your values and you're not getting a true statement, it could be that you have made an error. Now, I noticed earlier when people were asking me about that binomial squared, and we forgot the outers and the inners, or when I was factorizing and I forgot to take that negative over to the other side, there is so much possibility for error in signs, in addition of terms, in squaring binomials. There's just infinite possibilities where there's an error. So you should be made aware that if it doesn't work, go back. Have I made an arithmetic error or an algebraic error that I can correct? And then also, your substitution back into the equations, there could also be an error. So if you've already done it twice, maybe, and you've checked it, then maybe there's a mistake with the question itself. Or if you substitute back into the original, you could get an undefined statement, in which case those values would not be true. But that's very rarely that that happens. So I would really encourage you to do one of two things. Go back to the original and check the two equations, that you've copied them from the question paper correctly, that you've transferred onto your script correctly, and that you're transferring from line to line correctly. Even today in class, 3 students came to me with 3 different questions. One, the problem was that she hadn't transcribed the exponent. So she had left 4y plus 3y, and it should have been 4y squared. So if you're not transcribing correctly, error creeps in. And the other thing is, if you have access to Geogebra, and those of you who don't, you can just download it. It's free of charge from the internet, and you substitute your functions, or you copy your functions or your relations, because not all of them are functions, into GeoGebra, and you ask them to sketch it. Then you'll actually be able to see where your intersections are, because simultaneous equations are the solutions to 2 graphs intersecting. And if you check that out graphically, then there's a way of also testing whether those values are true or not. So That's it.
All right, because of time, I'll ask you the last question. Just the last one. I'm sure James can kill us. Tabet Njawulo says, why on the simultaneous equations you didn't use the quadratic formula at the end?
I don't like the quadratic formula. It's too big. It's too bulky. Could you tell from those three questions, if you go back to the notes, those were factorizable quadratics. So if they factorize, it's much quicker. But for those of you who love the quadratic formula, keep using it. You'll get the same answer, not a problem. Okay.
Cool, awesome. Thank you so much, Dina. It's been a great afternoon.
Pleasure.
Hope to see you again. Otherwise, Mindsetters, thank you for your time, grade 11s, and see you some other time. Peace.